Right, so welcome to the 8-1 notes, talking about polygons, interior and exterior angles. And so there's basically just two main kind of formulas we're trying to figure out today. First, the interior angles, right? The sum of the inside part of the angles. And so we already know for a triangle that the sum is always going to be 180, right? I mean, it could be 60, 60, 60. Right? If it was equilateral, 60, 60, 60, but even if it wasn't, it was like 30, 60, 90, or 45, 45, 90, or anything, it's going to add up to 180 degrees. But what about things for like four-side, quadrilaterals, pentagons, and there's actually a pattern. So basically what we can do is you can start with one vertex and just notice if you draw diagonals from corner to corner, how many triangles can you create? So for example, if I take a quadrilateral, let's say here's my vertex, and I just go like this, right? I've just created two different triangles. Notice I only start with one vertex. I don't start here, because then if I went like this, that would be overlapping. That's not how many triangles I have. You only want to count it once. So triangle has 3 sides, quadrilateral has 4 sides. The number of triangles we can form is 2. And so the sum would be 2 180s or 360. Right? Let's look at a pentagon. You can pick anywhere. Let me just pick this one. Again, you don't want to pick more than one vertex, otherwise you're overlapping. So I can go from here to here, and from here to here. And notice if I go from here to here, that doesn't really do anything, or from here to here, that doesn't do anything, because I'm not making another triangle here. So I really only have 1, 2, 3. For a hexagon, 6 sides, same thing. We just pick this one. It doesn't really matter. You pick any one. I can go from here to here, from here to here, from here to here. And again, this one and this one don't form triangles, so I have 1, 2, 3, 4. So let me pause. Let me fill that in here. So a pentagon has 5 sides, form 3 triangles, and so the sum would be 3 times 180. 3 times 180 is 300 plus 240, so 540 degrees. Hexagon, 6 sides, can form 4 triangles. So 4 times 180 degrees. 400 plus 4 times 80 is 320. 400 plus 320 is 720 degrees. And then so what we can just notice here, let's just see if we can figure out a pattern. So for a heptagon, 7 sides, I could draw 1, 2, 3, 4, 5. For an octagon, 1, 2, 3, 4, 5, 6. And so we just fill that in. Octagon has 6 sides. What you notice is that basically the number of triangles, we'll see if we can figure out what's the pattern here. The number of triangles is always 2 less than the total number of sides, right? So for a heptagon, we have 5. Octagon, we have 6. Pentagon, we have 3, 2, and just 1. Now, why is that? If you think about it, it's because these two are never going to be formed, right? When you try to draw diagonals, this one doesn't make a triangle, this one doesn't either. So you always have to subtract these two that don't actually make a triangle. So for a nonagon, right, you'd have 7 triangles. 1, 2, 1, 2, 3, 4, 5, 6, 7. And for a decagon, you don't actually have to draw all these. It's kind of getting hard to do so. 1, 2, 3, 4, 5, 6, 7, 8, right? So 10 sides, 8 triangles. There's always 2 less. So even if you don't have a picture, if it's 102gon, a polygon with 102 sides, that means you're going to have 100 triangles, right? So and then you just multiply by 180 to get the sum of the interior angles. So 6 times 180 is 1080. 100 times 80 is 18,000, which is strange. So again, the pattern is, right, the sum. If I want to find the sum of the interior angles, right, the sum for an n-sided polygon, okay, let's call that S sub n, right, so n is the number of sides. it's always, again, going to be, how do I get this? How do I get this number? It's always the number of sides minus 2, right? The number of sides minus 2. The number of sides minus 2 times 180, right? Because the number of sides minus 2 is the number of triangles, and each triangle is worth 180. So we'll say n minus 2, number of sides minus 2, times 180 degrees. So this is the first thing we have to remember for today. The sum is going to be the number of sides minus 2 times 180. So let's try a couple practice problems here. Okay, so practice applying. Okay, so let's try some practice problems. So again, we know now how to find the sum of not just triangles, triangles always being 180, but for any polygon, and you can kind of see it through the pen here. Remember the rule was the number of sides minus 2 times 180 will tell you the total sum of these guys. So first you need to just count the number of sides. So n equals, let's see, 1, 2, 3, 4, 5. So n equals 5, right? This is a pentagon. It's a pentagon. And so, I mean, if you have these memorized, you don't have to go and do the rule, but just to remind ourselves, so the sum, if n equals 5, we'll say s sub 5 equals the number of sides minus 2 times 180, right? Except in this case, n is 5, so I'll just say 5 minus 2, right, or just 3 times 180. Probably should put 5 here. Right, 5 sides. So it's basically 3 triangles, right? You can see, you can split it up here, 1, 2, 3. 3 triangles, and 3 times 180 gives us 540. 540. So again, how do I use this? Well, now I can just say this plus this plus this plus this plus this. These have to sum up not to 180, not to 360, but to 540, right? So 105 plus 115 plus 117 plus 100 plus x equals 540, okay? And from there, it's just kind of like algebra. If we sum these up, let's see, that's going to be 205 plus 15, 220, plus another 100, 320, plus another 100, 420, plus 10, 430, plus 7 more, 437, plus x equals 540. And then we'll subtract 437 from both sides. And so x has to equal, let's see, 103. Okay. If you want to pause the video and try this one, great. Go ahead and try it, or you can just watch. So for this one, we have n equals 1, 2, 3, 4, 5, 6, 7. N equals 7, which is called a heptagon. Heptagon. So the sum of 7, again, is going to be the number of sides, 7, minus 2 times 180. Right? So I don't have 7 triangles. I have only 5 triangles times 180. And again, if you have it memorized, you don't have to do this, but otherwise, let's see, 5 times 100 is 500. 5 times 80 is 40. So 500 plus 40, so 500 plus 400, excuse me, is 900. Right? So the sum is going to be 900. Now there's a lot of these here, so I'm going to switch pens because it's not going to fit. We just go ahead and write this all down. So we just kind of rotate this way. 125 plus 135 plus 130 plus 129 plus 116 plus 120 plus y equals 900. Right? 1, 2, 3, 4, 5, 6, 7. Okay, great. And if you add these up, I'm just going to wave my magic wand here and just you do it yourself. Add all these guys up. 600 plus 25, 35, 30, 29, 16, 20. We get 755 plus y equals 900. Subtract 755 from both sides, and we get y equals 145 degrees. Now, I don't have to put the degrees here because it's already there, so when you plug it back in, you get the degrees. Okay? So that's it for the interior angles. Again, the rule is it's the number of sides minus 2 times 180. Okay? Now, the last thing I want to talk about is exterior angles. Okay? Exterior angles. So What is an exterior angle? First off, we have to figure out what that means. And the way to draw an exterior angle is to take your pen and pencil, see if we can figure out this pattern. It's a little bit different. So I like to just rotate counterclockwise. You could do clockwise, but I'm going to do counterclockwise. And so just kind of extend out each line. So this is the exterior angle here. And then I'm going to keep rotating this way. So I'm going to extend out this way. That's this exterior angle here. And I'm just going to keep going this way. I'm going to rotate out this way. So straight, straight, straight. Okay? So what would these angles be? So just think about it. How could you figure it? If this was 80 degrees and you just made a straight line, what would this have to be? Right? These are supplementary. These are a linear pair. This would have to be 100. Okay? These are also a linear pair, supplementary. It's straight, so this would have to be 180 minus 45. So 180 minus 40, 140 minus 5 more, 135 degrees. And same thing with this one, right? 180 minus 50, which is 130, minus 5 more, 125. Okay, so the question is, what is the sum of these guys? Well, let's just take a look. Let's sum these guys up. 100 plus 135 plus 125, right? Again, these are exterior angles. These are ones on the outside. This is a different rule. Let's see if we can figure out what's going on here. Okay, sum up these. You got 100, 200, 300. Let's see, 300 plus 30 and 20 is 50. 5 and 5 is 10. Right, 300 plus 50 plus 10, that's 360. Okay, so maybe for triangles it's 360. Let's see if we can figure out what's, again, if you want to pause it, try it yourself, great. If not, follow along. I'm just going to rotate counterclockwise, draw some extra angles, straight, 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 straight. So let's figure this out. Again, these are a linear pair, so this has to be 80. Linear pair, so this is what, 30. Linear pair, so this is 70, right? Has to make 180. Also 80. Okay, so again, this was 3 sides, n equals 3. This was 4 sides, so let's see how this rule is different. So I'm going to add up all the exterior angles here. 80 plus 80 plus 70 plus 130. Let's see, that's 160 plus 70. 160 plus 70, that's 230 plus 130, so that's 300, 30 and 30 is 60. Huh. That's weird. It looks like for n equals 3 and 4, this was 360 and 360. But again, that doesn't tell us much. Let's say a few more examples. Again, we're looking at the exterior angles. So let's look at this example. 120, 120, 120. Add up those guys, and we still get 360. That's weird. How about this one? 90, 90, 90, 90. 4 times 90. Yep, also 360. How about for like a pentagon with 5 sides? Let's pick, again, this is not all pentagons, but for a regular pentagon, 72, 72, 72, 72, 72. Let's see, what would that be? 70 times 5 is 350. 2 times 5 is 10. 350 and 10, also 360. So that's weird. It seems like the sum of the exterior angles is always 360. But can we prove that, right? This is not a proof. This is just kind of a demonstration. Inductive reasoning. We think we see a pattern here. Let's prove this, why this has to be so. Okay. So notice that no matter the number of sides, the sum of every interior and exterior pair, right? What does this sum have to be no matter what? No matter if you have a 3-sided figure, or 4-sided figure, right? Or a 5-sided figure, right? And that makes sense, right? These are all linear pair, right? Always a linear pair. So this has to be 180 degrees, right? This linear pair. Okay. Also, just to set ourselves up for this proof, remember the sum of the interior angles, right? That's the inside, the part that we're not counting here. Remember that we figured out that rule was always n minus 2 times 180. Right? The number of sides minus 2 times 180. We're going to use that in a second. Okay. So to prove why the exterior angles is always 360, we're going to just use a generic polygon. So, I mean, it's a pentagon, but just pretend it really could stand for anything. We're just using letters, no numbers. And so let's prove, why does the exterior angles have to be 360, right? So we're going to prove, should have written it here, sorry, prove the exterior angles. So A plus B plus C plus D plus E, or for any polygon really, so if it was 3 sides, A plus B plus C is 360, no matter what, right? So we'll try to avoid using 72 degrees or 90 degrees. It's just these letters here. Okay? So as we mentioned, what's the sum of any one pair of interior and exterior angles? Right? Any one pair, right? A and A, B and B, C and C, D and D. Again, this is for not just 5-side figure, for any figure. Again, we said this is always a linear pair, right? This sum is always going to be 180 degrees, right? No matter how many sides, 180, 180, 180, 180, 180, 180. Every pair of interior exterior is always 180, right? So let's think about this. So what would be the combined sum of all of these different pairs? So 180 here, 180 here, 180 here, 180 here, and 180 here. So how many 180s? In this case, I mean, it's like 5, I guess, right? But 180, 180, 180, 180, 180, right? So in this case, you had 5 180s. In this case, you have 4 180s. In this case, you have 3 180s. So it's always 180 times the number of sides, right? 180, 180, 180. So 3 180s here, 4 180s here, 5 180s here. So it's always the total combined sum. It's always 180 times n, right? Times n. Right? I've got 5 of them here, or whatever. Okay. Now, notice that this is the sum of all interior and exterior angles. But basically, what I want to do is I want to remove the interior angles, right? If I subtract out the interior angles, then all I'm left with is the exterior, which is what I want. So let's remind ourselves, how do I get the sum of the interior angles, the stuff I want to subtract out? Remember that rule was n minus 2 times 180. Okay? So what we can do then is basically, if I take this sum here and I subtract all of these guys out, so from here, notice how I just kind of remove them. If I remove out all of these guys, I will be simply left with what I want. I'll be left with the sum of the exterior angles. Again, this is no matter how many sides it is. So how do I do that? So again, remember, I'm starting with the sum of all of them, which is 180 times n, right? That's all of these interior and exterior angle pairs. 180n. And then I'm going to remove the interior angle sum, right? N minus 2 times 180. So what would be removing? That's not adding, you're subtracting, right? You want to cut out n minus 2 times 180. Right? So if you take the combined and you subtract out n minus 2 times 180, you will be left with this. So let's just figure out what is that? What is this? So let's do some algebra here. So if I distribute, right, remember this is still minus all this thing here, so I'll put this in a bracket. So minus 180n, and then minus 2 times 180. 2 times 180 is 360. Okay? And then over here I had 180n. Right, so this is the sum, right? So this is, again, taking all the pairs, subtracting out the interior angles, and this sum should be what I'm left with. So the exterior angles should be left with this. But if you look, what am I left with? I'm left with 180n minus 180n. What is 180n minus 180n? It's just nothing. Oh, so I'm left with negative 360. But remember, you distribute this negative. A negative times a negative leaves you with a positive. So you are left with positive 360. Notice it doesn't depend on n. That's the really cool thing, right? It doesn't matter if it's 5 sides, 4 sides, 3 sides, 100 sides. It's always equal to 360. Again, the sum, right, for the exterior angles of any polygon, no matter how many sides, is always 360. It does not depend on n. Okay? So to finish, just to apply a couple problems here, how could I find this guy then? So for example, again, for the exterior angles theorem, we know that it doesn't depend on how many sides there are. The exterior angles is always just equal to 360. So it's a little bit easier actually. So I could just say, hey, okay, great. If I have this guy, but I have this guy and this guy as well, I don't have to know what these are. I could just say that 92 plus 123 plus the measure of angle 4 equals, not 180, right? I'm talking exterior angles here, is 360. And again, it's always 360 if it's 3 sides, 4 sides, 10 sides, it doesn't matter. Okay. I combine all these guys, oops, just these two guys, I guess. So that's going to give me 215 plus the measure of angle 4 equals 360. And subtract out 215 from 360. So I'm left with 100 and, let's see, 60 minus 50, 60 minus 10 is 50 minus 5 more. So 145 degrees. And you could double check that by plugging that in. 145 plus 123 plus 92 is 360. So if you want to pause the video and try this one, that would be great. If not, I'll do it in about 5 seconds. Okay, so let's take a look then to finish this off. Again, this has 1, 2, 3, 4, 5 sides, but it doesn't matter because exterior angles are always just 360. So I'm just going to add up 67, 75. Now this was tricky, y and x, so we'll come back to that. Here, what would this guy be? Do I have to call this guy z? No, because see the arc, so I don't know how much they are, but I know that because they're both supplementary here, and these guys are equal by the congruent supplements theorem, this has to be equal to this, so I can call this y. Okay? So y plus x plus 67 plus 75 equals, now again, exterior angles, always 360. Okay? The other thing we have to notice, right, this is impossible to solve unless we realize that x, right, is supplementary with 90, so x is also just 90. So by the substitution property, we can use 90 instead of x. Okay. So if we sum these guys up, 90, 67, and 75, we will get 232. Y plus y, we get 2y. Right? And subtract 232 from both sides. We get 2y equals 128. And divide by 2 on both sides. And we get y equals 64. Okay, and it also asks for x, so we'll say x equals 90. So again, if you didn't notice, if you got it wrong because you said y equals 128, it's because you forgot about this, that there was 2 y's, a y here and here. So it's not 1 y, 2 y equals 128. So y equals 64, x equals 90. Okay, our homework on this section 8.1 is going to be page 5, 10, 7, 8, 11, 12, 14 through 16.